Welcome to MyESAT's SAT Essentials video series. This is a 10-hour video, personally paced SAT program that's designed to provide quality SAT preparation to all students. The series is split evenly between the three sections of the SAT: math, writing, and critical reading. The lectures cover effective SAT test-taking strategies, review frequently tested topics, and provide practice problems that familiarize and prepare students for the real exam. The SAT Essentials video course is the foundation for all MyESAT courses and is used in conjunction with live MyESAT workshops. At MyESAT, our mission is to pave the way for brighter futures empowered by education for all students.
Hey guys, and welcome to Math Class 1 of the SAT Essential video series. First off, I'm stoked you guys are here because that means you're motivated enough to improve your SAT score. Well, either that or your mom is motivated enough to improve your SAT score. Either way, I salute you. Because today we're going to be covering some really useful stuff that'll help you in the math section come test day. Now, since it's our first math class, let me start off by introducing myself. My name is Ryan Sulak, and I'm your math instructor for this video course. I might look old now, but geez, I remember the time I first laid my eyes on the SAT. I was in high school, about 16 or 17 at the time. Probably around the same age as most of you right now. I went to high school in Coral Springs, and I had my hands full with classes, with sports, with thinking about girls. Girls. Oh, excuse me, I got sidetracked. Truth be told, I wanted to be a professional baseball player at the time, and SAT was the last thing I wanted to do, but my mom made me. And Mom, if you're watching this right now, thank you. Because honestly, it really helped. Her motivation, when it came time to apply for colleges, I found out, dude, my mom was right. All those times she told me I'd thank her for making me do those practice tests, well, I'm thanking her now. Because when it came time to apply to college, I found out that kids that studied for the SATs did better on the SATs. Who knew, right? And oftentimes that little bit better that they did on the SATs made a huge difference when it came time to getting into the college of their choice. And guess what, guys? Girls like guys that went to college. And guys like girls that have gone to college. So it might not be important to you right now, but it will be someday, and you'll thank me. I promise. And that's why we're here today, because I'm here to teach you how to do well in the SAT math section. Together we can do this. My goal is to teach you on this video course just some of the basics of SAT math. Is this everything you'll see on the test? No, definitely not, but it's the perfect place to start. This video course is a foundation for all of my eSAT Live personal coaching and instruction that will really help you do your best on the SATs. Now, as you work your way through this video, remember, it's not enough to just passively sit there and daydream and sleep slide after slide. I need you guys to be actively participating in doing the practice problems in class and taking the practice tests assigned to you, okay? I'm watching you, especially you in the back there. Okay, we're about to get started now. Don't forget to grab a notebook and a pencil. And if you don't have them in front of you now, just pause this lecture right now. Pause it. Okay, and go grab them, because I need you guys to be taking notes and actively working with me. That's how you're going to learn.
All right, meet our math TA, Jake. He's just a cartoon, but he's a good-looking cartoon, and he gets all the ladies in cartoon world. I mean, look at him. He's going to help us out by popping up here and there throughout the class, emphasizing important tips. Today's agenda, we're going to start off by going over some basic facts about the math section. I'm going to assume you don't know anything about the SATs. Let's say you're an alien just landed on this planet. First of all, welcome. You're probably at the right place because I'm going to cover all the SAT math basics starting from the ground up. Also today, we're going to cover key SAT test-taking strategy. Here we're going to go over and practice two super important math strategy keys that will help you rock out like a superstar in the SAT math section. First off, we're going to meet the math section. Before you can beat something, you gotta know what you're up against. On every SAT, there will be 3 graded math sections. The first 2 sections are 25 minutes each. The last section is 20 minutes. So when you count it up, there are 70 minutes total and 54 questions total in these 3 sections. Do the math, and that comes to 1 minute 15 seconds per question on average. Shoot, that's not a lot of time. This is a very fast-paced exam.
To put things into perspective, you've already been watching this video for 5 minutes. Wow. That means if you were taking a test, you should have already done 5 math questions by now.
Now, of those 54 questions, 44 of them are multiple choice questions, meaning you can choose from answer choices A to E, and the remaining 10 of them are grid-in questions, meaning you will be given a grid and you have to fill in the numbers yourself. Now let's talk about grid-ins. So grid-ins are a bit special. A lot of kids think these are the hardest math questions, but with a little bit of practice, there's nothing scary about grid-ins. Your grid-in Scantron will look like this. Grid-ins are the only questions on the SAT where there is no multiple choice bubbles. You have to figure out the correct answer and fill it in on the answer sheet. You need to write your answer in at the top and fill in the corresponding numbers below. Technically, the grading machine will only read the bubbling, but still it's a good idea to always first fill in the answer into the boxes at top, so you don't accidentally bubble incorrectly. A good tip is to always start on the far left column and grid as far right as possible. For example, if your answer is a 3, you would write a 3 on the top left column and then bubble it below. Voila! It's okay to leave all the other columns blank. Nobody will look at those. So what if your answer was a fraction? Say it's 2/3. Then you would write it on top, starting from the left. 2-3. Now go ahead and bubble in the corresponding bubbles. Notice that the last column on the right is blank. That's okay, just leave it that way. What if your answer was a really long fraction, like 2.666666? Now what do? You don't have enough columns. Well, you have to fill in as much of the decimal as you can. But the good news is, the graders don't care if you round up or if you just cut the decimal off. Here you see that we have bubbled 2.66. That's right, but if you wanted to round up and put 2.67, that's perfectly okay too. Both answers are going to be marked correct. Remember, you must grid in as much as the columns allow in order to be as precise as possible. Okay, because grid-ins are such a special beast, there are also special grid-in rules. A grid-in can never be a negative number, or a number greater than 9999. Think about it. That's because there is no way to fill those numbers in. Lastly, there is no guessing penalty for grid-ins. This is fantastic. These are the only questions on the SAT where there is no guessing penalty. Let's talk about calculators. Do you need a calculator for the math section? Those people who get rich making these tests up say no. Which is true. You should be able to work out these calculations by hand. But my question is, if you don't have to, why would you? I mean, if you were Batman, you could fight off the bad guys with awesome hand fighting skills, but why would you when you could use your awesome fancy gadgets? You could pull out a paper map, but why would you when you could use a GPS? You get my drift. Therefore, if you have access to a calculator, especially a graphing calculator, by all means, use it. Give yourself that advantage. And be sure to use the same calculator for your practice tests as you will for the real SAT. You don't want to spend time on test day figuring out where the pi button is, or trying to get the equal button unstuck after your baby sister spilled juice all over. It makes a huge difference to be familiar with the calculator you use. So please bring the same calculator you use in math class on the practice SATs into the test center with you on test day.
All right, cool. Let's move on to strategies. The really awesome thing about strategies is that they are 1, super effective, and 2, they require you to learn no new information whatsoever. That's right. Strategies will teach you how to approach SAT problems in the most effective way possible. They'll show you the hidden shortcuts and how not to get tricked up by trickster questions designed to test you. We'll jump into our first strategy after this short comic break.
Haha, I love sharing these comics with you guys. But as promised, now it's time to go over an important math strategy. This strategy is for algebra questions only. The point of this strategy is to use the multiple choice format of the test to your advantage. If you think about it, they give you 5 answer choices on the sheet, and one of them must be the correct one. Whoa! So in other words, you know the answer is right there staring at you in the face. You just don't know which one. Well, at least not yet. But since you know the right answer is somewhere right in front of you, you can use this fact to your advantage. So instead of solving the question, why don't you test the answer choices to figure out which one is right? You're like Goldilocks when you're going to sip one porridge to see if it's right or not. If it's not right, then you'll sip on another one and so on until you find the one that is just right. Wow! Genius! You don't always have to solve the question, you just have to test the answer choices. Let me show you how to do this. You're going to test the answer choices and you're always going to start with C. Why C? Good question. Let's think about it. Look at this SAT question here and look closely at its answer choice set. The answers go up in ascending order with answer choice A having the lowest answer and answer choice E having the highest. Ah, so that's why we always start with C. Because it's always going to be the middle answer. By plugging in C first, you are first testing the middle answer. If it doesn't work because it's too small, then you can cross off C. And also you can cross off A and B. Wow, that's efficient. Well, what if C turns out to be too big? Well, then you could just cross off C as well as D and E. Cool. So that's why you start with the middle number first.
So do you never need to solve another math problem again? Can you use this strategy on every question? No, that's the catch. Only use this strategy for algebra problems that have numerical numbers as their answer choice. So questions where you have numerical numbers in the answer choice, where you otherwise would have had to use tricky complex algebra, those are the best sort of questions for this strategy. I think you're starting to get it, but practice, practice, practice is key, key, key. Let's try a couple practice problems together right now.
So let's solve an SAT question together. We'll try it in 2 different ways. The normal way you learn in school, and the shortcut way with our new strategy. I'll give you a minute to solve. Okay, time's up. To solve this question, you factor the polynomials on the denominator and the numerator using the quadratic formula. You get x minus 3 times x plus 2 as the numerator and x minus 3 times x minus 1 as the denominator. You then cancel the matching factors of x minus 3 in the numerator and denominator. Then you cross-multiply by multiplying the 6 against x plus 2 and the 8 against x minus 1. Lastly, you simplify and solve for x. Conclusion: that x equals 10. Whew! That was a long process that definitely took you over a minute. Not only that, this was so complicated that it's very easy for even the most meticulous mathematician to make a careless error. Now let's try solving the problem using our strategy of Goldilocking. You have another minute. This time, instead of solving anything, we're going to Goldilocks answer choice C. So let's plug in 2 as x in the equation. Solving it out, we see that this equals negative 4 over negative 1, or 4. This is not the same as 8 over 6. Instead, it is too small. X needs to be bigger for both the numerator and denominators to be larger. So let's go ahead and eliminate answer choice C and also A and B. Now let's go ahead and Goldilocks in answer choice D, x equals 10. Solving this out, we get 8 over 6, proving this equation correct. Answer choice D is the correct answer.
Wow, see how much faster and easier that was? Amazing, and it was almost mistake-proof. Instead of trying to figure out the quadratic equation or whatnot, we just almost mindlessly plug in and solve. We Goldilocks the equation using choice after choice until we find the one that is just right. Sweet. Okay, let's try one more. This time, you're on your own. I'll give you 1 minute to solve the problem on the screen using the Goldilocks strategy. Good luck.
Okay, time's up. Let's go over the answer together. Right away, let's Goldilocks and answer choice C, x equals 4. This results in 256, which is much larger than 64. This tells us that we need a smaller number as x. Therefore, let's eliminate C as well as D and E. Moving on, let's Goldilocks and answer choice B, x equals 3. We get 64. Therefore, B is correct.
Alright, so to recap, when you come across a variable problem where the answer choices are all numerical values, instead of solving it, consider Goldilocking it. Start this strategy by first plugging in answer choice C, and then moving up and down, adjusting until you find a number that is not too big, and not too small, but just right. We'll cover this strategy and more in Workshop Strategy Key Set A. If you were to only take one of our math workshops, I would recommend taking this one first because it really covers and practices the fundamental SAT strategies.
Strategy 2. Hunt for the pattern. This strategy applies to the problems that seem impossibly hard. Questions like, find a 333rd term in a sequence. What? 333rd term? That's ridiculous. Let me tell you a secret. They're not actually that hard. The trick is to hunt for the pattern or shortcut in the problem. The pattern will lead you to the shortcut, so once you find it, it's a breeze from there. Let me give you an example. Solve this problem. I'll give you a minute. Okay, let's hunt for the pattern in this list. Let's write out at least the next 5 numbers in the series and see if we spot the pattern. The problem tells us that the first 3 numbers are 1, 3, and 4, and we find the next one by adding the preceding 2 numbers together. So 3 plus 4 gives us 7. 7 plus 4 gives us 11. Then 18, 29, 47, etc. Do you see the pattern emerging in relation to odd and even numbers? You know that there absolutely has to be one because the SAT wouldn't require you to actually list out 500 numbers if there wasn't a pattern. Okay, so the pattern goes odd, odd, even, odd, odd, even, etc. So we know that for every 3 numbers, 2 will be odd. So let's figure out how many rotations, or sets of 3 numbers there are in 500. Divide 500 by 3 to get 166 2/3 rotations, or sets of 3. Let's ignore the 2/3 part now. If there are 166 full rotations and 2 odd numbers per rotation, that gives us 332 odd numbers. But now let's go back to the 2/3. That tells me we weren't able to finish a full rotation of 3 numbers. So we still have 2/3 of the last rotation, or the first 2 numbers of it. So since our pattern says the first 2 numbers are going to be odd, add 2 to 332 to get 334 odd numbers total. D is correct. You once again have a minute to solve this following problem. So the first step is write out the first 5 numbers in each series and look for the pattern. Now this time we're looking for patterns in the relationship between a list of numbers. Okay, so notice anything? It looks like every number in list S is double that in list T. So if S is double T, then what percent greater is it? 100% greater, right? Well, A is correct.
So the SATs are filled with shortcuts, and it's all about finding those shortcuts and knowing where to look. It might seem confusing to you, but believe me, the SAT test makers aren't that creative, yo. It's all about recognizing those patterns and those tricks, and that's why practice helps so much. Believe me, if you practice, you will get better. We'll practice this strategy and cover more in Workshop Math Strategy Key, Set B.
Alright, let's end this lecture strong with a few practice questions. These will test you on the same concepts that we covered today. You will have a little over 1 minute for each question, and I'll go over the correct answers at the very end. Good luck! Time's up! Now, let's go over how we got the correct answers, starting with question 1. Question 1 reads, the first term of the sequence above is 3, and every term after the first term is negative 2 times the preceding term. How many of the first 50 terms of this sequence are less than 100? First thing you want to do with this type of problem is hunt for the pattern, right? The last thing you want to do is actually start listing out the first 50 terms in the sequence and count up how many are less than 100. Okay, so let's start by listing the next 5 numbers in the sequence, following the first 3 given to us, and see if we can hunt for the pattern. So we have 3, negative 6, 12, negative 24, 48, negative 96, 192, negative 384. Alright, so I'm starting to see the pattern emerge. The first 6 numbers are less than 100, obviously. But then starting at the 7th number, 192, the pattern becomes that every other number is less than 100 because every other number is a negative number, since we're multiplying by negative 2, right? Okay, so let's subtract the first 6 numbers from the 50 terms that we know are in the sequence, and figure out how many negative numbers there are starting from number 7. 50 minus 6 equals 44. Now there are 44 numbers in the sequence. All we need to do is divide 44 by 2 to get 22 negative numbers starting from number 7. Add back on the first 6 numbers to get a total of 28 numbers in this sequence that are less than 100. Ta-da! Alright, now question 2. Which is a solution to 9 to the xth power times 3 to the 3rd power equals 1 to the xth power over 3? So for question 2, just looking at it, which of our 2 strategies do we want to use on it? It's clearly a variable question, and the answer choices are numerical values. That means Goldilocking is the way to go. So normally we would want to start with answer choice C and plug that into x. But since x is an exponent and answer choice C is a negative fraction, that one's a little tricky to plug in. So I'm going to move down and start with answer choice D, 0, which is the easiest number to plug into an exponent. Why? Because any number to the 0th power always equals 1. Okay, let's plug it in. 0 for x. We get 9 to the 0th power times 3 to the 3rd power equals 1 to the 0th power over 3. Both numbers to the 0th power turn into 1s, and clearly 27 does not equal 1. So D is not our correct answer. I'm going to eliminate answer choices D and E, and move up to answer choice B, once again skipping C. Let's plug in negative 1 for x. Remember that when you take a number to the negative 1st power, the numerator and denominator flip. So 9 to the negative 1st becomes 1 over 9, and 1 to the negative 1st over 3 becomes just 3. Let's do the work, and it multiplies out to 3 equals 3. Well, that's clearly a correct statement, so answer choice B, negative 1, must be our correct choice. Alright, last and final question, question number 3. Let's take a look at this question. There are 65 more men than women enrolled in Smith College. If there are X women enrolled, then in terms of X, what percent of those enrolled are women? Once again, I see there is a variable in the problem, so it is a variable problem. But should I Goldilocks this bad boy? Let's look at the answer choices. There are variables in the answer choices, meaning we can't Goldilocks. we need to use a slightly different method and plug in a number for x. We'll go over this strategy more in our workshop titled Strategy Key Set A. What number should we substitute for x? I'm going to choose 100 because it's a nice easy number to work with, so x will equal 100. So if we say there are 100 women enrolled in Smith College, and the problem tells us that there are 65 more men than women, so 165 men, then take 165 men plus 100 women equals 265 students total at Smith College. Now what percentage of women is that? It comes out to 37.74%. Now all we have to do is substitute in 100 for x in our answer choices and find the one that equals 37.74%. The only answer choice that matches is answer choice B, making that our correct answer. Booyah!
Alright guys, now I have homework for you. You've finished the lecture for Math 1. After you finish watching Critical Reading 1 and Writing 1, it's time for some real practice. These strategies have given you some serious Kung Fu skills. Now go put them to use in the real thing. From Official SAT Study Guide by College Board, take Practice Test 2. And good luck. We'll practice the strategies in this lecture and cover many, many more in our live workshops, where you will work with a smart, engaging instructor who will give you the personal attention you need. Schedule your workshop at www.myesat.com.
This brings us to our end of class comic. Until next time, peace out, Home Slice.